This video is about Guirit, the GUI of Guirit, the Guirit solid modeler that we developed at the Technion. What I'm going to do now is I'm going to show you how to install it and then start to show you how to use it. So if you go to the website we just saw in the opening slide, you will get to this website, and this is the website of Guirit. And scrolling down the page, you will find automatic installation on Windows, and you will find this version, which is the relatively up-to-date, probably from the last few weeks. You can download it, run it, it will install automatically Guirit, and then you will run Guirit, and you will get to the next page that I'm going to show, which is in fact the Guirit itself. You have also an installation for a Mac. You can see it here. I have to say that we support, to a lesser extent, Mac. Mac is also up and running on Linux machines. You can compile it yourself for Linux. We are not providing self-extracting executable over Linux. So having said that, let's switch to Guirit. And when you run Guirit, you're going to see a web page similar to what you see over here. On the right, you're going to see the hierarchy. The hierarchy consists of geometry. The cameras, right now we have two cameras. Let me zoom in a bit so you can see both. You see one of them, here is one. This is the camera, the first one. There is another camera hidden here someplace. In perspective, here it is. This is the second camera. We also have two light sources. You see this is one light source. This is the other. We have the grid itself, which is this grid, and we have the axis. In fact, I can hide and show, and this is the thing I want to show you. Each of these elements, for example, if I right-click on one element, right mouse click, then there is a hide, and this will disappear. And if I click again, I can show it. I can also do it from the hierarchy by pressing the H for hide and S for show, and I can do it for each of these elements. In fact, I can do it also on the hierarchy. So if I do hide here, it hides both elements, and hidden elements are in fact gray colored here as well. Okay, so let's bring it back. When you highlight something, right now it's highlighted in cyan. I will show you how to control that if you really want to. And this is the hierarchy. In all geometry, you're going to enter under geometry unless you insert light sources or camera and so on. In fact, you can do it. You can edit a camera. You can insert a camera, you can edit the camera using light options, for example, but that's kind of more advanced, so let's wait on that. On the left, you will see some icons, and on the top, you will see some tabs. So the icons on the left allow you to, for example, to control one window, two windows vertical, four windows, or one again. You can do front, back, left, right, up, down, and isometry view, orthographic, and perspective. Okay, in fact, you have two views here, camera one and camera two. You can switch with them by pressing the space button, the space key. So here are the two views that we currently have. We have one orthographic, one perspective. There are ways to add cameras, and again, I might show you later on. And here you're going to see some tabs that shows up. This is for animation, this is to control the axis, this is for controlling the system. So this is kind of configuration, this is for controlling the grid, the mouse, OpenGL options, and OpenGL, default OpenGL for new objects. So in all, you do want to go check these tabs, but do so when you have time. The defaults are reasonable, but if you do want to play with them, and you do definitely want to know them, and I mean, we might go especially for the OpenGL setup. So having said what we want to say about the right and the left, let me comment a little bit about the bottom. The bottom row show you some information, like how many polygons are in there, and what's the frame per second now, and what's the mouse state. And this will be useful for you when you want to see what we are doing right now. So if I press, for example, Control mouse left click, you will see Control CLD, Control left down. You can see now Control left mouse down. We can do Alt, we can do combinations, like let me try to do some combinations. Here is Alt, Control left down. We can do middle, and this obviously pops up some information from WX. Apparently, this is a special keyboard key configuration of theirs. So you can follow what they do with the mouse also with these messages on the bottom right. When I hover over geometries that are highlighted, and this hover geometry will tell you in the middle properties like the XYZ location, the UV parameter in the parameter space of this geometry of the surfaces in this case. Let's create a simple surface just for the sake of seeing this. This is a simple cone. You see that now I hover over the cone and I see the UV coordinates and the XYZ coordinates of ST cone 118. And in fact, it showed up here. This is the first geometry we are talking about. If I highlight stuff here, it's also highlighted there, and vice versa. If I highlight stuff here, it will show up here. And here I also hover and see the local information of the specific points. Obviously, stuff that is highlighted can be used further, but let's wait on that. So seeing this, again, I can hide it with an H, for example. And now let's start to look left and right on the top bars. So if I want to load geometry or load a whole new scene, what we call GTD file, Guirit text data, GTDs, I can save a scene, save all scenes. I can have multiple scenes. We'll see it shortly. I can create a new scene completely different. Let's press this one now. And as you can see, I have two scenes. I have this scene here, which is the active scene. I have the other scene. If I click on it, let's show this. So you can differentiate. So this is one scene. And if I click on that, I go to the empty scene. If I click on that, I return to the previous scene. So in fact, by clicking here, I can switch between scenes. And this is what we mean when we say save all scenes. So in fact, I can have more than one scene in Guirit. So let's go to the empty scene. Matrices and scripts will wait for now. I can save an image of this entire screen, or you can save the configuration. Configuration is important because if you go into all these panels, like you go into this panel, there are many configurations like the highlight color that is right now cyan. This is coming from here. And this is the auto highlight controls whether or not we want to auto highlight geometries or not. Now it's back on. You can save all that, not by saying, okay, here, this would not save it. But when you say configuration here, it saves it under this file over there. So now the configuration that I have now is saved. Okay, so we covered all that. Obviously, Exit does the expected things. We can go to Windows. Windows is very similar to this. It's more convenient because it's convenient to do it all the time. So you can see these are exactly identical to these four, and these views are exactly identical to these views. I can jump from previous and next views using this. And I can go to full screen, for example, and go back with an escape. And I can do the OpenGL properties that you can see over there. We'll go to there later on. This is useful in the sense that it allows you to switch the arrangement of the windows, the different sub-windows in Guirit. So this is a mode we use for scripting, and I will get back to this maybe later. And this is the normal mode. This is where we start usually. You can again switch to the scripting mode and save configuration. And when you do save configuration, it will save that configuration. So it will start in scripting mode if you prefer. Okay, so objects. Object allow you to manipulate object, but we don't have object yet. So let's wait on that for now. Let's go to CSG. CSG allow you, we created already a truncated cone, allow you to create primitives. Here is a box, and right click watch what's going on here. Right click here, essentially change the slider. So right mouse click and drag vertically, right mouse click up and down, right mouse click up and down, right mouse click up and down on all yellow widgets will allow you to affect the parameters. So in this case, we are affecting the minimal point and the dimension. So here is a box. And I can do a sphere. Here is the parameter of the sphere, the center. Let's move the sphere aside. Okay, so I have this sphere right in here. Again, I can change the radius if I'm not happy with the radius. And I have another sphere. These are all polygonal geometries. You know, I'm going to return to that shortly. And I can do the same thing for others. And I can do also Boolean operation. Now, the Boolean operation depends on what the input is. Now, the input is polygonal. So let's do an intersection, for example. And left mouse click, select out of the geometry root. Geometry root is exactly this geometry root here, the active scene. So out of the geometry root, what I have is box and a sphere, because this is what is shown here. So I can select either one. As first entry, I select either one. As second entry, and the Boolean operation is computed. So this is the intersection, okay? And it creates a geometry in the same shape, same icon shape or picture as the icon itself. So you can recognize that this is a box immediately, this is a sphere, and this is the intersection. And you have other operations, you have some control over the tolerances that I'm not going to go into detail now. Now, you can control the way the geometry is created. I can create primitives, each of those, almost, to be honest, as a polygonal, as we did, as a surface, as a model, as a trivariate, as a singular trivariate V model, and singular V model. V models and singular V models are volumetric geometry, so they are allowing you to represent full volume heterogeneous geometries. Trivariates and singular trivariates are the same, but they are not really a whole model. They're just one entity, one trivariate, like one surface. Model is a B-rep solid, so it's just a boundary that is closed. We are going to experiment with model shortly. And surfaces are essentially the primitives of model. In fact, surfaces are the primitive of model, and trivariates are the primitive of V models. And there are some singular cases that are more efficient to create, but they can have their Jacobian. So let's do model. And again, let me make a box. And you see that the box has now isoparametric lines in yellow. These are the parameterization, result of the parameterizations. And then let's do a cylinder. And let's make the cylinder thinner and move it to the center, more or less. Let's take it up. I have to say, and this is something to remember, that we are not supporting singularity. So if this top face of the cylinder will be coplanar with the top face of the box, the result might be unpredictable. Such singularities of collinearities and so on are not really supported. So always try to make the intersection transversal. Okay, so we have these two primitives. And again, I'm going to do now a whole. So I'm going to subtract. Now you see, these are hidden, like gray, because they are hidden. And the box is the first. This is the box that I know that is this box. In fact, I can also look here. Look at the bottom when it says ready now. You'll see that this is box 151. These are unique IDs. And so I'm going to select it here, 151. And same thing, the cylinder is 153. So I'm going to select cylinder 153, and I'm going to do the Booleans, and this is the Booleans. So this is the abstraction. So this is a model. If you point on a geometry, it will pop up some information that this tells you that B subtract is a type model constructed by Boolean subtraction. One model, the first model has 8 surfaces and 18 trimming curves. So you get some information on each of those. So if you look at this, this is one cylinder model, because we created a cylinder primitive model, one model, 4 surfaces, 6 trimming curves, and so on. So you get some hints from looking at that. Okay, let's hide that. So we saw CSG. Geometry is kind of advanced. I'm not going to go into all the details here. Okay, so let's start with painting on surfaces. But before that, we need a surface. So let's create a surface under surfaces. We'll return to surfaces later on. I'm going to create this truncated cone. It's a spline surface. And let's go back to geometry and let's do painting on surfaces. I'm going to select the surface. Now with the control left mouse click and drag, I can paint the current mask. The current mask is square. In fact, I can click the point and you will see the square. Or I can choose other masks. Let's see. Let's change the color of the mask to be, say, yellow. And let's change the mask to be smiley. Okay, so now let's take a different zone in this geometry. I'm just clicking now. Actually, the yellow color is not a good color because it's almost invisible. Let's do red. You can click smileys and you can see the smileys. And again, I can click and drag. Then you won't see much. So clicking on click and drag, and this is kind of fun. You can create a geometry with texture. Second thing is paint on meshes. So let's hide this. Let's create a polygonal mesh this time. And I'm going to show you how to change the number of polygons in the geometry. That's the finesse here. Make it 64. You see that this geometry is much smoother. And I'm going to manipulate this geometry using polygonal mesh editing, which again, these small triangles shows up opposite different option. I'm going to show only this option. Taking the geometry now, if I click and drag now with a control, I pull up some regions, or I can push, in fact. You see now it's a hole, and I can change the magnitude of the affected zone. So let's make it 0.5. And I'm pulling a much bigger geometry and another kind of interesting ability. Let's look at impossible object. For that, I need two views. Both of them are going to be isometric to begin with. And let me upload this time pre-existing geometry. So I'm going to, under File, we'll do Load Geometry. And then I'm going to go into the Guirit sources. Exactly what is installed in yours. In fact, you have the same models under the installation directory of Guirit. Under Impossible, I'm going to load Impossible 1. Impossible 1 is an impossible object. It is impossible because if you look at this square ring and this bar, the bar goes below the ring here. In fact, you don't expect to see this portion, you expect to see that portion. Let me hide the hide the camera and the light in addition to the grid. And so you see that this is really strange. This is kind of impossible. This is in continuation of the kind of the belief that we look at this geometry and there are 90 degrees here and 90 degrees in this joint and 90 degrees in this joint, but in fact, it's not true. You see the skew geometry there. And the way we create skew geometry is, in fact, I'm going to hide this and I'm going to show you the geometry before the deformation. So now everything is normal. You see from above, the bar you see from above, but yet you see the bar in front here and behind the square ring. So that's kind of more normal behavior. And this is again, kind of normal. So what we do in this impossible objects, I'm going to select the box, the bar, the red bar, and I'm going to shift it. Okay, so I need the global linear shifting. I'm going to shift it in the line of sight of this view. So you won't see much changing here, but you definitely will going to see stuff changing on the right. You see stuff is moving quite a bit. I skewed only one of the geometries. I didn't move the ring, so it didn't affect anything. But now you see the geometry almost the same as in before. From the view of the line of sight, it looks almost the same. And yet I see the bar from the front. The reason is that we deform the geometry, we skew the geometry along the line of sight. And so this is a way to create impossible geometries. Okay, so let's hide all that. And let's go to, let's try deformation. Deformation, we have 3D and 2D. I'm going to try 3D deformation. I'm going to take a box. So I need a CSG, I need a box. This is the box. Let's go to one view again. Let's return the grid so we'll have some reference. Oops, I want the grid. Here it is. And I want the formation. So 3D deformation, and again, I have to select an object. I'm going to select, I forgot to create the box. You see, there can be only one DLL at a time, so I have to say, okay. So now I have the box, and now I can go to the formation. I want the formation. So one DLL at a time, so if one DLL is entered, the other one goes away. Okay, so ignore these 4 lines. I'm not going to talk about that. But using the handle that you see on the left and right, and I want to change the maximal edge length. I will explain shortly what it's doing before we do that. So now I can, in fact, with the control left mouse click and drag, twist the geometry. Twist it in both ways. So it's kind of doing what you can expect to get. And you can deform geometry in a nonlinear fashion using these controls. Okay, so this is the original poor cube. Okay, this essentially refined the geometry. You see the polygons there. If I return back to the original state of 0, so there's going to be no refinement. And let me start all over with no refinement, because when it's refined, so we're going to select it again, the box. And if I do the same transformation again, you see that the box is like one solid shape, because there are only 6 faces and 6 polygons, and in fact the polygons are not even planar. It's kind of really weird. They have to be 2 triangles, so you see the entire division there on the silhouette kind of side, but this is really not what you wanted to see in a nonlinear deformation. In fact, now it's really getting crazy. In fact, you get some very poor polygons. The magenta shows you that it's inside, that if I will go to a much finer resolution, I will get a much better result. Okay, so this is a little bit about the formation. Let's go to import. We can import images. We can import text too. I will show that also. I need to plot a square, and then the pop-up shows up. And I need to select an image, and I know I have an image here. So I'm going to select this image. It's in fact the opening page of Guirit on the web. And so I can create as many images as I want. I can apply now. Apply means commit. And I can create another one here and another apply and another one here and another apply until I'm happy. And okay does apply and then quit. So now I'm done. And again, let's clean everything so we can continue with the clean domain. I'm going to skip the others. There are also kind of other applications here. I'm going to show you this application. This application allows you to upload 2 images, and I need to go to where I have images. In fact, we can process in Guirit several types of images. We can process PPT images, which are PPM images, sorry, which are images on a kind of a low level. I'm not sure if you're familiar with that format, but we also fully support GIF, JPEG, and PNG, which are much more common. So you can select either one of these images. Here I'm going to select PPTs. This is what I have here. I need at least 2 images for this application. And now something pop up. You don't see much now in this application, but let me reduce the point size of what we plot here to a much smaller size. Okay, so now you start to see something. In fact, you see here a person, I bet you recognize the person, at least recognize a person. This is Ben Gurion, one of the Jewish leaders. Oops, and here is Herzl, another Jewish Zionist leader. In fact, this is a cloud of points. What you see are a bunch of points, just a bunch of points in space that together detail in 3D 2 images. This is one image, and this is the other. And in general, this is just a cloud of points. And in fact, we etch these points on glass cubes using lasers. And this is kind of cute to see two orthogonal images encoded together. You can also play with that with 3 images. So this is one thing I wanted to show. Let's see if there is anything else here I want to show. Let's go to here. We can do ortho letters. That's also fun. Ortho letters allow you to etch 2 orthogonal letters independently. 2 orthogonal words independently, to be more precise. Here you see amor. You see here love, and the 2 letters are love here and more there, so we can change all that. We can say this, and we can say here that. Oops. That. And this will work as well. So you can do any what letters you want. That and this. Note that the top of the T here is missing because this is related to the D. So it has to be of the same height. So if you can do all uppercase, it would work out better. We can also make it solid. I'm looking for to do it now. So if the output is solid, in actually 3D geometry, that looks that from here and looks this from here, and this is also kind of fun stuff. Okay, so let's go to more theoretical stuff. What we have here are kind of applications of our nonlinear multivariate solver. We have a very strong spline-based nonlinear multivariate solver, and I'm going to show 2 examples for this. This is called the Malfatti problem. You can imagine it's from the Middle Ages. You can imagine a marble with a cross-section, a marble rod with a cross-section of the triangle that you see over here, prism if you like, and we want to fit the 3 biggest circle that can fit that prism. The idea is that this is made of marble, that's the original Malfatti problem, and I want to extract the 3 biggest cylinders extruded out of it. So this is a solution that is as a result of 9 nonlinear quadratic constraints. And in fact, I'm going to change the locations of the vertices control with a right mouse click and drag up and down, so you can change all the locations of the 3 vertices. And again, you see the 3 biggest circles that you can fit in. In fact, I have to hint that it's not always the 3 biggest circle. Under extreme cases, it won't be, but this is hinting about the also efficiency of our solver, that you can get such a solution of 9 quadratic equation in real time. This is the second example I'm going to show. This is related to something called the Stewart platform. And let me say another thing in this movie is that if you stand on a title of a application, and by the way, all these are DLLs as they're implemented. So in fact, many of those are individual DLLs. There are quite a few DLLs in the kernel of Guirit. If you stand on the tip on the title of the DLL, you can see some hints that if you double click, you get the help this way. So you can double left mouse click here, or you can just hover until it pops out. You will see that. Anyway, the Stewart platform is a robot that has a stationary plate here and a movable plate there. And the movable plate is controlled via 6 rods that you see over here. And these 6 rods change length. So by changing length, and I have 6 rods, I have 6 degrees of freedom. In fact, I can create all the expected degrees of freedom of 6 degrees of freedom of rotation and translation. And you can see it here. There are some singularities. There are, in fact, many solutions here because, in fact, here I have, if I'm not mistaken, 12 quadratic constraints. But if you carefully control the amount of motion that you allow, and always the thick edge is the edge that is actually changing length, you can get the most plausible solution. And this is what we present, the most plausible solution. Okay, so pretty much covered everything here. And now it's time to, let's clean everything. Go back to the original view and let's switch to curves. Okay, so let's talk about curves. And we're going to start left to right with circles. So the easiest curve we can create are circles. There. Again, I click on the small triangle to get the pull down menu. is circle and center. So here I can change with the right mouse click and drag up and down, change the radius, and here I can change the position and even lift it in space. So now it's actually above the XY plane. The grid is always in the back, by default, in fact, in the XY plane. And I created a simple circle. There are other ways to create circle, like from 3 points. So now I have to click and drag with the left mouse and Control Shift. The Control Shift left mouse click and drag will actually allow you to move the points. You cannot move the center. This is just for visualization, but you can actually move the point and create a circle from 3 points. We can create arcs, we can create ellipses. Let's do ellipses also. This is ellipse by setting the center and setting the major radius and setting the minor radius, the other radius, and so on. There are, again, other ways to create ellipses. In fact, we can also create conic sections there, but let's go to more interesting cases of splines. So we can create splines, and I'm going to go to front view. It's easier because all these curves are 2D. By clicking point and interpolating them, we can make the curves periodic or change the parameterization to be chord length, and there is some place here I can also change it to be periodic. Here it is. So now it's closed. I can change the degree. It can be cubic, it can be quadratic, again cubic and quadratic. This is interpolatory. You can actually control the interpolatory behavior from here. So that's one way of creating a spline. Another way is by sketching. And let me kill this one. I can try and sketch simply by sketching a shape, which is Control left mouse down, and I just plot. Just drag. I create a shape. In this case, it's almost like a face, and I can make it again periodic. That's going to be closed. I can make it float end condition, open end condition. I can change a degree. And this is called the least square fitting of the approximation is controlled from here. So now it's going to be less control points. We can do even lesser. Let's do 0.5. And again, with the right mouse click and drag, I can actually change this number between 0 and 1. Okay, so that's the second way. Let's hide this. We can actually create text on fonts. See an example. In fact, I can do a language. I can do Hebrew. So this is also supported. These are fonts of the system. So now I type ABC in Hebrew, Aleph, Bet, Gimel, and you can see that as well. So other fonts are supported. All the outline fonts that are in the system are supported. You can select from here all the outline fonts that the system is supporting. I don't know what this font is at all. Here is another example. And I can make it also different types. So I can do outline B-spline, now it's outline Béziers. I can do solid 3D trim, so now it's actually trim geometry. So this is not just curve, even though it's under the curves tabs, but it's mostly for curves. Okay, so let me hide this. Here you see the entire hierarchy of this. Again, H hides this. I can create Hermite. I'm going to skip that. Bezier. So again, I'm going to go to front view. Again, this is a Bezier curve. So I click on the control points and create control points with Control left mouse button. But if I do Shift and Control and then click and drag with the left mouse button, I can actually move around control points. And we have the same pretty much for B-splines. So now I create a B-spline curve. Now the degree is specified, so there is a degree. Oops. This is degree 4. I can make the degree 3 or degree 2, which is exactly coalescing with the control polygon, and go higher until it's actually going to disappear because there are less control points and degrees. Again, I can do the open end condition or periodic end condition, pretty much the same, floating end condition, and so on and so on. Okay, so other advanced ways to create geometry, including arrangements of curves, intersecting curves. I'm not going to talk about it here. We have ways to create primitives, like then I click on the small triangle, so I can create a spiral that you see here, a sine function, or, and you see the sine function here now, actually, created. Or I can create a helical curve, and this is what I'm going to play with a little bit more. You see the helical, I can control the number of loops, the pitch, This is the pitch of the helical shape. All these shapes are approximation, so I can control the approximation, but how many control points per loop and how many samples per fitting a least square. I can make more loops, less loops, and I can change obviously the size of the helical shape. So all these again are approximation. I can do many manipulations on curves, and I'm going to show you just one, like evaluating position, tangent, normal, bitangent, curvature, intersection of two, and so on. And I'm going to just do the tangent. For that, I'm going to select the helical shape that is still here. And you see, this is a tangent at point 0. In fact, the vector of the tangent is shown in the origin because it's a vector, but also along the point where it's actually tangent to. And so again, I can move around. You see the tangent running around the helical shape while the tangent in red rotates and the tangent in yellow is actually going up at the point of a tangent, and just changing the parameter. I can make it unit length, or I can make it actually the actual derivative of the shape, so it can be non-normalized. Okay, let's delete all that. We can also do a lot of editing operations, and for that I need to create some shape. So let me sketch again a shape. I'm going to sketch this shape. Now, with this shape, I'm going to do editing multi-resolution. There are several ways to edit geometry. I'm just going to show you one of them. And so here I can edit control points. Control Shift and then left mouse, click and drag. I can move a control point. Or I can do direct manipulation, what we call multi-resolution direct manipulation, in which I click and drag and the entire shape is moving around. Now the effect can be global as it is now, like 50% of the shape, or can be much smaller, like 5%. Now it's going to affect a much smaller zone of the shape. Okay? So I can do either global direct manipulation or local direct manipulation with the multi-resolution. In fact, there are some wavelets bases going on around below that. Okay, so what else do we have? We have region from curve. Let me show the sketch curve again, and I can extract, you see, divide and raise and reparameterize and extract region, refine, and so on. All the thing you can expect. You can do also offsets. Look, let's do extract region. The sketch, and now I need to select the domain that I want to affect. So you see, this is the beginning of the domain, and this is the end. And I can extract the region that I want. Say this is the region. So I'm left only with that. Finally, we have some symbolic operation. Again, these are advanced tools. I'm not going to use that. In fact, we're going to show some composition examples on Trivariate splines later on. Okay, so we are done with the curves menu. Let's clean this up. And let's go directly into the surfaces menu. So in the surfaces menu, we can use curves that we created before. So let me just create some curves quickly, like I can create circles. I'm going to create this circle. Apply, again, apply, just commit and doesn't leave. I'm going to create another one over here, apply, and then make one smaller and make even a fourth one. Oops, I didn't apply here. And then a fourth one here. And I'm going to hide these three for now and use them later on. Okay, so now back to surfaces. Surfaces can be created in all ways. You can actually directly create shapes, surfaces by clicking points, but this is kind of low level, so I'm not going to show it here. You can do the same thing with B-spline. You can create a plane from 4 points. Let me hide this circle as well for now. So basically, you can set the planar region, you can set the minimal, maximal in both directions, and you can elevate the plane. You can change the elevation. In fact, you can change the order if you want higher order or number of control points in this B-spline geometry. So this is kind of the basic primitive. You can also create primitives here, the same as we build with CSG if I selected surfaces. This is essentially the same. Like you can create a tori, for example. You can change the parameter, the major radius, the minor radius, and so on. But this is more interesting because these are really high-level constructors. So we are going to skip some of them. This is either meet, interpolation, bilinear. Bilinear just get 4 points, and you can change the points in the bilinear. Essentially, the plane is a subset of this. Extrude. Extrude, I'm going to show you this circle. Extrude takes a circle, and I'm going to select the one that is not hidden. This is this circle, and it extrudes the surface in the dimension, in the direction that is shown here. Okay, so in this case, it's Z, but it can be a different direction. In fact, you can also scale the vector here using this, or you can taper it. Taper to 0 will create a cone. Okay, and this can be arbitrary shape. Okay, so that's extrusion. We have ruling between two curves. So if I take, say, this circle and that circle, and I can rule a surface in between. So I'm going to select, again, this circle, the two that are not hidden, and that one, and I ruled geometry. And again, I can set up the degrees in the ruling direction. Okay, so now we want to switch to surface of evolution. Before I do that, I'd like to introduce a feature I didn't discuss until now, and that is related to right-clicking on the geometry here. Oops, I'm sorry, I want to show this. Right-clicking on the geometry here and then transform, and you can do the same thing here. Right-click here and then transform. This operates on the object that is now selected or highlighted, and I want to select 3D transform. And a frame will pop up, and the frame will have abilities to translate the geometry along the pinkish cubes that you see there, or boxes, or even in Z. You can also rotate it using the yellow bars, or you can scale it by the green spheres. And I'm going to use this to move this circle off the center. And in fact, you can also do non-uniform scaling on these boxes by control. If you do control, you do a non-uniform scale. And so I have now a circle outside the center. Now I can use the surface of evolution, and I can select the curve. And I can see the geometry. This is the surface of evolution. I can control if I want a full circular or less so in both directions. And so I can create a surface of evolution this way. Okay, there is something called Boolean sum and Boolean one. These are Boolean sum is a special case of Boolean sum. If I have the circle, and another way of the menu that I'm going to use now is reset transform. Reset transform will bring it back to the original shape. It forgets about the transformation that I applied earlier, because I want to use this circle to do Boolean one. Boolean one essentially converts the geometry into a disk. So it fills in the entire plane using 4 curves around the closed shape. So you can take any closed shape and divide it into 4 curves and do Boolean sum on top of that. Another constructor, that's why I wanted all the circles, is what we call surface from curves. Basically, I can now select the 4 curves. It's actually skin surface around these 4 curves. It can be arbitrary degree, it can be cubic, it can be higher because I only have 4. It can be linear. If I do it like this, you can also ask it to interpolate. Now it's actually interpolating the shape, or just approximate. It's your call. And you can create these surfaces as well. Okay. There's higher advanced shapes here. A constructor, I'm going to skip it. Sweep allow you to take a section like a circle. Maybe we should try it. Let's try to take this circle. Let's take this circle, but again, I'm going to reset its Z. So again, I do something that I didn't do earlier. Edit geometry. Edit geometry takes you back to the constructor, and then I'm going to reset the Z value to 0. So now it's the beginning. I'm going to make it even smaller. So basically, I have 2 circles. So the cross section is going to be the smaller circle, this one. the trajectory curve is going to be the bigger circle, and you can guess I'm going to get a tori out of this. In fact, I can also apply a scaling along the sweep and so on and so forth. That's another constructor. We can do stuff with trim surfaces. We're going to talk about it now. Again, we can do lots of evaluation of normals, tangents, and so on, silhouettes, and so forth. We can also edit geometry. I'm going to skip that. Extract region, maybe I will show that. I showed it for the curve. So I'm going to select, say, the sweep that we created. Now I can extract a region out of this in this direction. You can see it now, and I can change the direction to be the column. So now I can extract a region in the other. Okay. Again, symbolic comparison and sketching that I'm going to skip. So now this is what I wanted to say about surfaces, more or less. Let's switch to trivariates. So again, let's go to the canonical view. Start exactly where we always start. And keep some of those. Let's keep the curves, even though I don't care for the surfaces, because you know what, I do care. Let's keep it because I'm going to use them. So again, I have some constructors of trivariate. If you're not familiar with trivariates are essentially functions of three variables, u, v, and w, and it create a volumetric entity. Remember that we started at the basic stuff with CSG. We talked about ability to define trivariates from here too, but you can also do trivariate constructor like extrusion. So for extrusion, I can only select surfaces, and I have the Boolean 1 disk, for example, that if I extrude it in the third dimension, this is the third dimension, I create essentially a cylinder, skewed cylinder in this case, that is volumetric. It's a trivariate function of three variables. Okay, and similarly, I can do a rule volume of that. So if I select the first surface, okay, now I need two disks. It's going to be challenging, but you know what, let's do two disks. So we have the Boolean 1, this one. Let's do Boolean 1 on this circle too. Let's see. Let's do Boolean 1 to this circle too. So we need circle 52. Surfaces. Boolean 1. 52. And so I have two disks. So now ruling volume means ruling between two surfaces. And so I'm going to select the Boolean 1 here, and I'm going to select the Boolean 1 there, and I get a cone, truncated cone, which is a volumetric entity. And we have similarly volume of evolution and skinning of volume through a bunch of surfaces, Boolean sum volumetric, Boolean sum, Boolean 1 volume that is volumetric, and so on and so forth. And we have the ability to raise degree and so on and so forth. So this is pretty much advanced. That I'm not going to talk much about this. And we have the same panel that you saw on the left here. We also have more or less the same there. And I'm going to talk about this a little bit now, at least about the OpenGL, because that's very important. I mean, this OpenGL here or here is the default behavior. If I'm going to change this, for example, to blue, every new entity that's going to be created from this point on is going to be with this default color, which is blue. So let's go to surfaces, create a cone, and the cone is going to be blue. So again, this here and the same thing in the panel is the default behavior that you can go and save configuration, it will store that. However, you can also override that clearly. So if you right click again here or right click again there is a rendering options here also. And if you do this, you can change the color, say green. But you can change many other things. You can change, for example, isocurves to be blue. And you can change the number of isocurves in one axis and in the other. And in fact, if it's volumetric, you also have a third way. And you can change the tolerances. So if I'm going to get something really crude, it's going to be looking really ugly. And this is the other, this is the polyline crudeness. So you see that the polylines are very crude now. The one that are seen here. So we can change the way we tessellate. There is a uniform tessellation option, which is what we apply now. Or there is the adaptive option, which was the default. And we can do many, many other things. Let's disable this. You can see the control mesh of the geometry. You can see the polygons of the geometry. These are the tessellation of the polygon. Again, this is adaptive, but you can also have uniform tessellation, which is what you see over here now. And we can, let me hide this. You can see the boundary curve. We don't have any, but you can see the silhouettes. And again, I can control the color of the silhouettes. Let's make them black. I can create shadows. I can show the discontinuity curves. Say this color. Let's enable discontinuity so you can see the discontinuity there, and so on and so forth. In fact, knot lines is interesting because knot lines show you just the location where you have interior knots in the parameterization of the spline. You can show also normals. The normals are reversed inside, so you have to reverse them to see them pointing outside. You can see normals of the polygons or normal of the vertices. You can select the length of the normals in all this visualization. You can show bounding box and you can apply texture and so on and so forth. So this is very useful menu to set the way geometry is drawn. There are many, many options here. I only showed several. Okay, let's see what else do we have here. Let me clean this. Let me clean everything. And let's go back to the original view. So now, we pretty much covered everything except the object. I'm going to return out the object and show you some of the abilities that we have here on manipulating objects that are, now that we know to create an object, can be useful. So let's talk about this. For that, I'm going to show you one application that is quite interesting again, which is related to geometry that I skipped. I talked about the stuff from here. I didn't talk about the stuff in here. You can place multiple entities along a curve, along a surface, or inside a volume. And I'm going to focus only on that. These are a simpler case of that. So this aggregation of geometry in a volume is a very useful application we do recently in the last several years. And then I'm going to load some example from the examples that you already have in the installation of Guirit. So again, I'm going to go to the installation. Again, under models, and there is DDM this time, and I'm going to select square tubes. Now this again loads a fairly complex scene, and you can see a very complex geometry here. This is the aggregation, the same aggregate that we see over there. What this does is takes a trivariate, the same trivariate that we saw here off a duck, and maybe I should show you that example first. You see there is a Boolean one, which is trivariate, which is what I'm going to show now. This is a trivariate volume in the shape of a duck. It was created using Boolean one of a surface that basically I'm going to show you now. That's the surface. Let me hide it. And that's the duck. Let me hide that. And I have a tile, and the tile is this tile that I'm going to show now. It's this tile, and this aggregation in a volume places elements of this in the domain of the trivariate and does a surface trivariate composition. These are the surfaces that are linear B-splines, and compose the linear B-spline that you see over here inside the trivariate duck I showed you, and the result is this. So now let's go back to here, and let's edit geometry. You already saw me doing this before. And here I can change parameters. I selected the Boolean, volumetric Boolean sum of the duck, and I selected the tile. It's actually remember that. And I can change the number of tiles in the geometry. So now it will do twice as many. You see that now there are twice as many tiles in one direction. Let's do the other direction. It takes several seconds, so we'll have to be patient here, but now it does the second direction. It actually does twice as many tiles in the other direction. So now we have many more tiles in the other direction, but we have 3 directions. So let's do the third. Another 10 seconds, and you will see the aggregation in the third. So this essentially creates a very smooth geometry. The smoothness is governed by the shape of the duct in this case, the trivariate, and the shape of the tile in this case. Here it's done. Let me complete the operation. And this result is a spline geometry, typically of higher order, that is fully compatible for everything else we did here, but it has many entities inside, in the thousands, if not more. So using this, I'm going to show you some examples from object. You have, in fact, you can point here and see how many elements we have. We have, this one is one element. This one has 1008 elements inside. But I can use, for example, random RGB and select this aggregation, and it will color every individual element here in different color. Everything is now more complex because it's pretty slow, but you can now, and I'm going to shrink this one to be smaller so you can see the geometry. Every tile is in different color. In fact, the inside, as I mentioned, is magenta, always magenta. And so, and you can see the individual tiles and actually hover over them so it's highlighted. Okay, so that's one way. We can also explode that. That's going to be very difficult to see, but let's try it out anyway. Everything is exploded now. We have an exploded duct with all the elements. And you can control the amount of explosion. Okay, so there are many other applications. You can merge objects, split object, convert object with different types. In fact, you see the conversion here. What do you want to convert it to? So this is the object. This is all the abilities to convert to. You can mirror object, duplicate objects, selection of subsets, and so on and so forth. And with that, we pretty much covered everything.